In the vast, silent theater of the cosmos, a star is born. Not just any star, but ours. The Sun, a colossal sphere of incandescent plasma, reigning supreme at the heart of our solar system. For billions of years, it has been the unwavering source of light, warmth, and life. A constant presence in our sky, shaping our world and our very existence. But how much do we truly know about this familiar yet profoundly mysterious celestial giant? Join us on a journey to the heart of our star, to witness the power, the fury, and the breathtaking beauty of the Sun. To grasp the Sun's sheer scale is to confront our own smallness. If the Earth were the size of a single grape, the Sun would be a gigantic sphere you could barely fit inside your house. It's so massive that you could line up 109 Earths across its diameter. In fact, it contains over 99.8% of all the mass in our entire solar system. Everything else, all the planets, moons, asteroids, and comets combined, is just cosmic dust in comparison. This immense mass generates an incredible gravitational pull, a force so powerful it holds our entire solar system in its orbit, from the scorched plains of Mercury to the icy depths beyond Neptune. We are all dancing to the Sun's gravitational rhythm. So what powers this celestial behemoth? The answer lies deep within its core, a region of unimaginable pressure and temperature. Here, in a furnace hotter than 15 million degrees Celsius, the Sun performs an extraordinary act of cosmic alchemy, nuclear fusion. Under this crushing pressure, hydrogen atoms, the most abundant element in the universe, are forced together. They fuse to create helium, and in this process, a tiny fraction of their mass is converted into a tremendous burst of energy. This is the secret of the Sun's fire. Every second, the Sun converts about 600 million tons of hydrogen into helium, releasing more energy than humanity has consumed in its entire history. This energy, in the form of photons of light, begins an epic journey from the core. It can take a single photon over 100,000 years to travel from the core to the surface, bouncing through the dense plasma before it finally escapes into space. And from there, it takes just over 8 minutes for that ancient light to cross the 93 million miles to Earth, warming our faces and illuminating our world. When we look at the Sun, we see a seemingly calm, uniform ball of light. But this is a grand illusion. The Sun's surface is a roiling, chaotic landscape of unimaginable violence. We call this visible surface the photosphere. It's not a solid surface, but a turbulent sea of plasma, bubbling and churning like a pot of boiling water. These bubbles, known as granules, are each about the size of Texas, and they live for only a few minutes before being replaced by new ones. Scattered across this fiery ocean are dark, cooler patches known as sunspots. These aren't actually dark, but appear so only in contrast to the brighter, hotter surroundings. Sunspots are areas of intense magnetic activity, regions where the Sun's powerful magnetic field lines burst through the surface. They are the visible signs of the Sun's inner turmoil, and they often serve as the launching pads for some of the most spectacular events in the solar system. From these regions of magnetic intensity, the Sun unleashes its fury. Towering loops of plasma, called solar prominences, can erupt from the surface, extending hundreds of thousands of miles into space. These graceful yet powerful structures can last for days or even weeks, held in place by the Sun's magnetic fields. But sometimes, the magnetic tension becomes too much to bear. The field lines snap and reconnect, releasing a cataclysmic burst of energy known as a solar flare. A single large flare can release the energy equivalent of billions of nuclear bombs, blasting radiation and charged particles out into the solar system at nearly the speed of light. These are the moments when the Sun truly reminds us of its untamed power. For us on Earth, the Sun is the ultimate giver of life. It's the engine that drives our climate, our weather, and the ocean currents. Photosynthesis, the fundamental process that underpins nearly all life on our planet, is powered by sunlight. Plants convert sunlight into chemical energy, forming the base of the food chain that sustains us all. The Sun's light dictates our days and seasons. Its warmth makes our planet habitable, and its energy is stored in the fossil fuels we've relied on for centuries. Without the Sun, Earth would be a frozen, lifeless rock adrift in the dark. It is our celestial parent, the source of our past, present, and future. Our connection to it is absolute and unbreakable. We are, in a very real sense, children of the sun. But our star's influence extends beyond gentle warmth and life-giving light. The sun also creates what we call space weather. Along with solar flares, the sun can eject enormous clouds of plasma and magnetic fields called coronal mass ejections, or CMEs. When these solar storms are aimed at Earth, they can have profound effects. As the charged particles slam into our planet's magnetic field, they create the beautiful, shimmering curtains of light we know as the aurora borealis and aurora australis. But this beauty hides a potential danger. A powerful solar storm can disrupt our modern, technology-dependent society. It can damage satellites, interfere with radio communications, and even overload power grids, causing widespread blackouts. Understanding and predicting space weather is becoming increasingly critical as we venture further into space and rely more heavily on our technological infrastructure. We must respect the sun's power, not just for its ability to give life, but for its potential to disrupt it. Like all stars, the sun is not eternal. It has a life cycle, and it is currently in its comfortable middle age, about 4.6 billion years old. It has enough hydrogen fuel in its core to continue shining as it does now for another 5 billion years. But eventually that fuel will run out. When it does, the sun will begin its dramatic final act. The core will collapse and heat up, causing its outer layers to expand enormously. The sun will swell into a red giant, becoming hundreds of times larger than it is today. It will engulf the inner planets, Mercury and Venus, and possibly even Earth. Our world will be vaporized, returned to the star that gave it life. After this phase, the sun will shed its outer layers, creating a beautiful, expanding cloud of gas and dust called a planetary nebula. At the center, all that will remain of our magnificent star will be its cooling, dying core, a white dwarf, a dense, Earth-sized ember slowly fading into the blackness of space. From a fleeting photon's journey to the epic lifespan of a star, the story of the sun is a story of time and energy on a scale that defies human comprehension. It is a constant reminder of the dynamic, violent, and beautiful nature of the universe. It has nurtured life on our small blue planet for eons, and its eventual demise will mark the end of our solar system as we know it. For now, it burns. A beacon in the cosmos, a source of wonder, and the star we call our own. As we continue to explore the heavens, we are ultimately just trying to better understand our place in the universe, a place made possible by the unwavering fire of our sun. Thank you for joining us on this journey. Subscribe for more explorations into the cosmos.